Now we have seen that how we can calculate the address given that two-dimensional array, that how we can calculate the address of an element that we want to find. Now let's generalize this. So first we have to understand that what are the things that we have considered here. So this one represent that we have to cross exactly one column. So how we will get this one is from, suppose I want to go to an element I cross j or I comma j. Let us write that I want to go to a I cross I comma j element. So here we want to go, as we have considered 2 comma 1 or 2 1 position, I will write it as 2 comma 1. So I becomes 2 and j becomes 1, as simple as that. So how we'll get this one is we are crossing exactly one column. So I will be this one can be written in general by using this j. So we'll write it as j into. Now suppose we have a m cross n matrix or m cross n two-dimensional array where m is the number of rows and n is the number of columns, which is pretty obvious. Okay, so next is this 3. That means each and every column will have elements equal to the number of rows. Okay, so here this 3 will be denoted by, as we have considered 3 cross 4 matrix of which is two-dimensional array. So we can write this 3 as m plus. Now we have seen that once we cross this first column, this column is crossed, then we'll have to cross these two elements, and we can cross these two elements by considering the rows. So how we can get this 2 is by considering this 2, because we are going to the element 2. Okay, so this can be I multiplied with the size of each and every cell, plus previously we have considered that our base address will be 100. Now the base address will be whatever it can be, so we write it as base address. So this is the general formula of Aij. Okay. Again, I am telling you that you can easily derive this formula. You don't have to by heart anything. You just understand that how we are considering, how we are finding out the address of a single element, and then you can easily derive this formula. Okay. You can take any other element. Suppose you can take 2 2 or 1 3, and then just trace out that if I is 1 and j is 3 and m is 3 and n is 4, then how your how this formula will work. Okay, you can just trace it out by yourself. And the next important thing is that as I am starting from my array index 0, what if I start from array index 1? Okay, let me write that what will be the changes if I start my array indexing from 1. So indexes will be 1 2 3 4 5 6 7 8 9 10 11 12, and the elements will also change. So the elements will be 1 1 2 1 3 1, 1 2 2 2 3 2, 1 3 2 3 and 3 3, 1 4 2 4 and 3 4. Now suppose you want to go to this 1 2 element. See, I am not going to do this. You just trace it by yourself. You just do it as an assignment. It will help you to clear your concepts more. I'm just going to write the general formula, that how you can derive it. The general formula is just simple. You just need to subtract 1 from this, multiply it with m plus I minus 1 into the size plus the base address. Okay, this is the general formula of Aij if the starting index is 1. Okay, how I am getting this formula? By just tracing out in this way. I am not going to derive it completely. I leave it as an assignment to you. You just do it by yourself and see that how you can get this formula. Okay, now we have completed both row major order and column major order. Now we shall see some examples on this, which will help you to clear your concepts more, and then we'll move to our next module. Okay, fine.